What is up YouTube? Welcome back to another episode on Code with Annie, and I apologize for this delay in the release of the videos because I was held up with some personal work and it's been more than 6 days. So I was not feeling 100% today as well, but I just wanted to put this video out because I feel I was becoming a little inconsistent and this video has to go in today. And sorry for keeping you guys waiting for a long time. In this video, we're going to take a look at the overview of thread pools and the different helper classes and interfaces that are available as executors. Now, why do we need a thread pool first? So instead of us creating and managing the threads and their lifecycle, the Java programming language also provides some executors or some mechanism by which automatically the threads are created and managed. You don't have to worry about the lifecycle of those threads. So that is the purpose of the executor and executor service and all the helper classes that are present here. And they will create a pool of threads. Basically, pool of threads refers to a group of threads, and those threads will be managed by the executors, and you just have to give the task to the thread pool and it will automatically perform the executions using the threads that are available in the thread pool. Now, this is a very important concept, and there are a lot of interview questions surrounding these concepts as well with respect to concurrency and multi-threading. So do bear with me in this video and understand very carefully what I'm trying to explain, because this is a very crucial concept. All right. So in the last video, if you recall, I was trying to create two threads by myself and was calling the produce and consume method to show you the producer consumer wait notify protocol. Now in this video, I'm going to explain you how you can use the executors and a thread pool executor to perform the very same task. Although the execution I will show you in the next video, but for this video, I'm just going to explain you the core principles. Okay. So the executor and executor service are the interfaces which are present in Java, and the executors is a helper class which provides some of the implementation methods for the executor and executor service. Basically, if you want to create the instance of these two, you use the executors and you call certain methods such as this one, new single thread executor. Now, difference between executor and executor service is that executor operates on a single thread. So when I say executors.new single thread executor, it will give me an instance of an executor. It will give an instance of an executor, and executor.execute is the method that is present in the executor. Okay, and this will accept a runnable task similar to how a thread accepts, right? When I say new thread of I pass a runnable task to it, right? Same way I can pass the same runnable task to the execute method. Difference being, I don't have to create the thread or start the lifecycle of the thread. Instead, the execute method will automatically handle all of those things, including maintaining the creation of the thread, moving from runnable to running state, handling wait notify, and everything will be done by the execute automatically. Okay, so you don't have to worry much on that. So that is the purpose of the executor interface. Executor service is just a little bit more enhancement on that, but it provides something called as a new fixed thread pool. Again, if you see the differences, I'm just using a different method, but the core helper class is same, which is the executors helper class. Okay, I'm saying executors dot new fixed thread pool, and in this one I'll pass the number of threads that I want to create. Here I'm saying 10 because this will create 10 threads in the fixed thread pool. Okay, and it will use these 10 threads to perform any runnable task that you give it, right? So if I say executor service.execute task 1, task 2, task 3, all the 3 tasks will be executed using the threads that are present in this thread pool. So that is the beauty of executor service versus the executors, which will give you a new single thread executor. Even executor service can give you a single thread, that is absolutely fine. But when moment you switch to an executor service, you're obviously aiming to utilize the fixed thread pool. So the concept of thread pool starts from this particular interface instance using the new fixed thread pool. So this is the way you create the objects for executors and executor service, okay, using the executors helper class. And this is how you call the execute method. Automatically, it will pick up 3 threads from this pool and execute each of these tasks one by one. All right. Now, there is a father of these two methods. Father of these two interfaces, which is, by father, I mean it's a much larger than life. Not larger than life, basically much more powerful implementation called as a thread pool executor. And this is a class, basically not an interface. And you can create an instance like this, new thread pool executor, and you can see it accepts a bunch of parameters here, right? Basically, this is a very basic constructor for thread pool executor. It can accept more parameters as well, like thread factory, but here I'm telling you the core thread pool executor constructor. It accepts 5 parameters. This is called as the core pool size. This is the max pool size. This is a a value, and that value is associated with a dimension, which is the time unit. So when I say 1000 and I pass seconds, it means 1000 seconds, and final parameter is a blocking queue implementation. In this case, I'm using an array blocking queue of size 50. So what are these basically? So when I say core pool size, what I mean by core pool size is the core pool size basically is the initial threads that are created by the executor, by the thread pool executor. Okay, so it creates 2 threads. Okay, max pool size is the second parameter, which basically is the max threads that the TP can create. Now this max pool size, don't confuse it, it actually includes the core pool size as well. So when I say max pool size 5, it means that I can have 5 threads at max created by the thread pool executor and managed. Okay, that includes these 2 as well. So when 2 is already created initially, you can create 3 more, and that will be your maximum capacity, which is 5. Okay, keep this in mind, don't confuse, it is not 5 plus 2, it is basically 2 inclusive inside this 5, so it has a max capacity of 5. All right, then you have something called as the time to live. Okay, so that is basically your 1000 and this time unit. So I am saying 1000 seconds here. So this is the time, maximum time up till which the thread which is idle will be able to live. Okay, I think I just something here. Okay, I moved the bracket, I think. Sorry. I did something here, I think. Yeah, now it's fixed. So time to live is basically the total time up till which the thread which is idle in the core pool will be able to live. Let's say there are 2 threads here, right? One of them is running, one is idle. The idle one can stay idle only up to 1000 seconds, after which it will be terminated automatically. So that is the time to live. And the array blocking queue basically is the queue that accepts your runnable tasks for execution. Okay, time till which the idle thread can remain in pool. Okay, and finally the array blocking queue is the queue of tasks. Basically when I say task, I'm saying runnable tasks. Okay, so you can have 50 runnable tasks put in this queue, post to which if I have one more task coming in, so what happens initially is you have 2 threads, right? And I have 50 tasks queued, and 2 of them are already in use, and 2 more come in, and this size becomes 50 again, but these 2 are still executing, and you have one more task come in. Then the thread pool executor will go ahead and look at the max capacity, which is 5, so it will start creating one by one 3 more threads. Okay, because 2 is already there, 3 more will be created, and 3 more tasks will be pulled out of this queue for the threads to execute. And again, if it reaches the 50 mark, that's when your thread pool executor will start to decline the tasks. It won't even accept it because you're already full capacity. Okay, so keep these parameters very carefully in mind, because there will be a lot of twists and turns on this one, and if you know this thread pool executor, it will be very helpful for you in multiple interviews when you tackle concurrency questions. Okay, so that was it for this particular video, and if you liked it, hit the like button, subscribe to Code with Ani if you haven't already, and I'll see you guys in the next one. Bye bye.